Guten Tag, hello and hola, and welcome to the 7th, I believe, C tutorial. And today we will be looking at a subject called arrays. Now, again, I have already created, and I have... Okay, this is definitely become an in-series joke that I haven't clicked. Or at least to me anyway. Because I'm a sad person. So, we're going to do our main.c. Go. Again, and we're going to go down to int main, create our function as normal, and turn 0. So, what we're introducing today is something called arrays. Now, what an array is essentially a bundle of integers. It's not a bundle of integers. It can be a bundle of any data type you want, provided I think the exception to the rule is void. So, unless you avoid pointers, I think you can do that and array them. So what you can do these is it's essentially a way of grouping a load of integers under a single name. And it's quite interesting how it works, because if you it might not make sense to you that you can store 10 integers under the same name. But how it works is that integrated within this array, the compiler generates a pointer to this array, and it creates a block of memory, say however big the data type is, times by the number of actual numbers or characters in the array. So that's how it works. So whenever you want to go to a certain element in the array, the program increments the pointer, so it points to the piece of memory. It's like, as we explained with the addresses, what you can do with pointers is you can increase their size by adding and subtracting from them. You can't multiply and divide though, and that basically moves up these addresses and allows you to point to different pieces of data than it was already done. So that's how it works. So let's declare one. Now note, this is an incredibly important thing that you need to know. Whereas in regular maths, say the stuff you've been taught at school, you start counting from 1. With arrays, you start counting from 0, at least in C. In other languages, that might not be the case. In fact, I'm quite sure in something like Lua, it isn't the case. So anyway, you go 0, 1, 2, 3, 4, instead of going 1, 2, 3, 4, 5. So how do we assign these things? You can assign them in numerous ways. What we can do, is we can go, yes, we can assign the various numbers. So what this does here is that it goes through each individual element in the line and it assigns a number. So go 1, 2, 3, 4, 5, 2, 0, 1, 2, 3, and 4. That's one way of assigning it, and that works fine on when you're actually creating these variables. But say we want to change something, like say we want to change my array 3 to say 42 because it's the meaning of life. But you can just do that as if it's a regular variable. Heck, not to if you don't get confused with this, you can even do this. So what this does is it assigns it to the 0th in the line, so 0. So from what I understand, if I recall, I don't generally use it. I generally go like this because it's good to clarify. In fact, I'll do that just to clarify it. You can test it in code. I might be wrong because I don't generally do that because it's not a good idea. Is what I would generally do is that would assign the 0th, like as I say, 0, the first element in the array, 32. But I'm just going to do that to make sure that I'm not wrong. So we can also print them as well, and we print them in the same way as regular variables. So we go, and the various things. So we go my array. So we want to print out 4. And that's arrays. And you can do this with every single data type. You can do it with characters. Actually, there's quite an interesting way of doing it with characters. I'll show you. Because you may have heard me mention about strings in printf. So this is how you define strings at a basic level. You can also use pointers as well. But even I'm not entirely sure with that, because that's annoying. Because sometimes I've written things and I've decided to go with fixed boundaries, because when that happens, sometimes bad things happen with pointers, because I think I've fundamentally misunderstood. So what you do is you could assign it like that. You could just assign every single one like that. But if you want a proper string, which means it's something called Null Terminated, you type this. So what this essentially does is it puts like the 0th byte, it makes it equal to 0. No wait, no it doesn't. It makes the last byte, so after the R here, the next byte in this array is 0. And what this does is that it stops it printing out the rest of memory. Now, it's not so much possible in C as it is in assembly. That's why I got you to download an Asm thing, because I'm going to do a assembly tutorial at some point, hopefully. But what it does is it decides to print out the rest of your program, and while that is hilarious, that's not particularly useful. So that's the reason why we null terminate our strings. So let's get around to compiling this. Please compile. Let's call it. And that works. I admit this is admittedly isn't as hands-on as the other ones, because I couldn't really so much as... I mean, I could obviously make an incredibly interesting program with these things. I mean, programs all the time are written with them. I mean, every single game that you've ever played will probably have an array in there somewhere. Even if it is written in assembly and was programmed in 1981 for MS-DOS or ZX Spectrum or whatever, it will have arrays of some form in there, because it is simply not efficient to have various identifiers. Unless, of course, you're playing a few of my old games, and like fan-made games, or ones that are very, very, very simple. I'm talking like text adventures, and even they generally use strings. So I could do that. Oh, and by the way, if you're watching this because you want to get ahead in the competition, you're not allowed to. I'm being frank here. You are stopping at tutorial 6, and you are only using your knowledge from 1 to 6 to sort of consolidate that knowledge. I will create another challenge at tutorial 12, I believe, and you can always use all of the stuff that you've learnt here prior to create something decent there. So, thank you for watching. I hope you enjoyed this as much as I did, and I will see you around.